Hi there. Welcome to video 10, which is a video working through all the AQA Higher Unit 3 exam questions on volume. You should have watched video 9, the volume tutorial, and made some at least one revision card or more, and now you should be ready to attempt these questions. As I've said previously, these questions are particularly, and these videos are for pupils attempting the higher paper having previously sat the foundation. Just to warn you in advance, there may be a couple of topics that weren't fully talked through in video 9, namely the concept of density in the following questions, so you may want to make yourself a revision card if you encounter the topic of density and you don't understand it. As always with these videos, I'm going to show you a question. After 10 seconds, I'm going to start working through the question. So you pause me, you have a go at the question, and check whether you're getting the right answer when I go through it. So here we go. First question, have a go yourself, and in 10 seconds, I'll go through the answer. Okay, so we've got a cylinder here, and it tells us various things. It tells us the diameter is 14, the height of the cylinder is 12. It asks us to work out the volume, and it gives us 4 marks. Now, probably you've got 3 marks for working out the volume, and you get a mark for giving your answer to a suitable degree of accuracy. Okay, well, how do we work out the volume of a cylinder? Well, we can work out the area, the cross-section area of one of the sides, like the base. Okay, we can work out the area of that, and we multiply it by the height of the shape. Now, it tells us in the question the diameter of the circle, okay, is 14 centimeters. So we know that the radius of a circle, of this circle, must be 7 centimeters. We work out the area of the base or the top, it's the same thing, and we multiply it by the height, which is 12 centimeters. That would get us our volume. Okay, so area of circle, let's start off and break it down. Area of circle, well, you should know the formula for that. It's pi r squared, and in this case we've said r is 7. So on your calculator you do pi times 7 times 7. And you would get for that 153.94. 153.94, and the unit is centimeters squared. Okay, and now to work out the volume, it's the area times by the depth. So you do that number, 153.94 multiplied by 12, and you would get 1847.26, and the unit centimeters cubed. Now, that would get us 3 marks, a suitable degree of accuracy. Well, what I would say is it gives us the lengths to 2 significant figures, so there would be no harm in giving the answer back to 2 significant figures. So you put a line after your first significant, the second significant figure, and therefore rounded to the nearest 100, this would be 1,800 centimeters cubed. That would have you 2 significant figures. I would just tell the examiner 2 significant figures. Okay, take a look at the next question. As always, pause the video. In 10 seconds, I'll go through the workings for this. Okay, let's take a look at this. Shape of a flower bed is given in a cuboid, and here are the dimensions of the cuboid. It tells us the following. For every meter cubed of soil weighs 1.25 tons. A gardener wants to fill the flower bed with soil as cheap as he can, and here is cost from 2 companies. What company should he use and how much? Now, company A, it's a certain amount per ton, and company B, for 10 tons it's 430, and then £67 per extra ton with free delivery. Okay, obviously, let's work out how much this flower bed would weigh in tons. We know that every meter cubed of space or volume it takes up is 1.25 tons of mass. So let's work out how much volume it takes up. Let's do the easy calculation, the volume. Well, we know the volume of this shape is the cross-section area times by how far back it is. So that would be, the height here is 1. So it's this area here times by how far back it goes, which is 2. So the volume must be 6 times 1 for this area, and then multiplied by 2. And that would give us 12 meters cubed. Now, how much does it weigh? So the weight, well, for each meter cubed it's 1.25 tons, so we have 12 of them. So we do 12 multiplied by 1.25, and we get, this would be 15 tons. So 15 tons. Okay, we've probably got 2 at least easy marks there. Now we compare each company. You would have more space. I've cut out the amount of space you'd have, but let's do company A here. It's £49.50 per tonne and 30p delivery. So if we've got 15 tonnes, it would be 15 times £49.50. Okay, and it would be, add on to that, £30 delivery charge. Now 15 times £49.50 is £742.50 plus the £30 delivery. You get a total of £772.50. Okay, so that's how much it would cost for company A. I did the same thing for company B. I'd have a lot more space than I've got here, but company B, we need 15 tons, so 10 tons are for £430, so it'd be 430 for the 10 tons, and for the remaining 5, for each of them it's £67.50, so 5 lots of £67.50. You work that out, so you do 5 times £67.50 plus the 430 for the first 10 tons, and you get an answer of 767.50. So which one is cheaper, Company A or Company B? Well, clearly Company B. So the answer is Company B. How much? £767.50. And that was 6 marks. That's very doable in the higher paper for 6 marks. If you work out your volume, then your weight, then work out price for Company A, price for Company B, write down which is cheaper and say how much it costs, that's 6 really quite straightforward marks. Okay, next question, as always, pause the video, have a go, and then watch the solutions and check you get the right answer. Okay, it says the diagram shows a triangular prism. What's the volume of this prism? Well, we know from our previous video that the volume of a prism is the area of the face times by how far back it goes. Now, this area, let's work out the area of this triangle. Well, we know the area of a triangle is base times height, 10 times 2, divided by 2, which would be 10 centimeters squared. So the volume is that area times by how far back it goes, namely 3.5. So we would do 10 multiplied by 3.5, and we would get 35, and the unit, centimeters cubed. So 35 is our answer. Now, we didn't cover this in our video, but it's a question on density. You might want to write yourself a quick revision card based on what I say here. Density of wood is 0.4 grams per centimeter cube. What's the mass? Now, either you know what density is as a formula. So some of you may know this. Density is defined to be mass divided by volume. Okay? Hopefully you might know that. Okay? So rearrange that. If you want to work out the mass, it's density times volume. Some of you in science may have learned it with triangles. If that works for you, then you can use that. So you might have a DMV triangle. Whereas if you want to work out density, it's mass over volume. If you want to work out mass, you cover mass, it's density times volume, etc. Or what I think is the best way is most of the time in the question they give you the units of density, grams per centimetre cubed, and per, this sign here means divide. So if you're just clever at spotting the units, you get for free the formula that density is grams, which is mass, divided by centimetres cubed, which is volume. Okay, so it's one less thing you've got to remember. So if you want to work out mass therefore, the mass would be the density times the volume. So mass is density times the volume. And you know the density is 0.4. You know that the volume is 35 from your previous question. So you simply do 0.4 times 35. And you get 14 as your answer. Well, what's the unit? We were using grams in our density, so it's grams here. So the answer is 14. So maybe you need a revision card stating that formula and you learn it, or using the triangles that you may have done in science and learn it, or better still, you look at the units in the exam and you work the formula out for free. Okay. Next question, as always, pause the video. In 10 seconds, I'll work through the answers. Okay, so let's have a go through this. Sally's buying a radiator for her bedroom. Her room is 2.4 meters high. So it gives you the plan. The plan is the bird's eye view, but we know that if this was three-dimensional, let's say, and it's not drawn here, if we had the three-dimensional picture, we would know that the room is actually 2.4 meters in height as well. Okay, so just remember that. It's 2.4 meters in height. It says you can work out the heat output using the following formula, work out the cost of the most suitable radiator. Now, all of these formulas are given how much volume the room is multiplied by 42. So the first thing we need to do is work out the volume. So really what we've got here, let's just draw it out in another diagram so we can see the three-dimensional aspect of it. We've got a room, if we can imagine this, a room where the flat of it, if we look at it from above, and maybe the width of it is 4.2 and the depth back is 3.1, but we also know from the question that the height of the room is 2.4 meters high. So this height here is 2.4. Okay, so it's not quite as accurate as I liked it there, but we know that this height here is 2.4. So we need to work out the volume. So the volume is the area of this front face here. So so this here is 2.4 high and 4.2 across. So you do 4.2 times 2.4 for that area, and then you multiply it by how far back the room is, which is 3.1. So you multiply it by 3.1. You type that all in your calculator, and you get 31.248, and the unit meters cubed. Now the heat output, therefore the heat, again you would have more space in the exam, I've cut the amount of working here. The heat is the volume of the room times 42. So you do 42 times that number, 31.248, and you get 1312.416, and the unit is watts. Okay, so from here you want the room is going to have an output of 1312. Which radiator does it for you? Well, A doesn't, it only gives you that output. B doesn't, it's not enough. And C does. So work out the cost of the most suitable radiator. Well, the radiator is radiator C, and the cost is £220, and that will do the trick for you. Okay, next question. Again, pause the video, have a go yourself, and check the answers with me after 10 seconds. Okay, it says that boxes go into crates. Each crate measures as follows, each box measures as follows. Okay, so what we're saying here, let's just assume that that distance there We care about that distance there and that height there. Okay, let's write these down. We think, just assume that's 210 centimeters. This one is 120 centimeters back, and let's say that's 100 centimeters high. And each box measures as follows. So this would be, let's do it with this box here, it would be 8.4 that way, going back 6, and high, let's say 4. Okay, each box makes a cost of is £4. When it's sold, it's a profit of 50%. How much profit is made? Let's just do something easy and work out the profit on one box. So profit, one box. Okay, well if it costs £4 to make and you make 50% profit, 50% of £4 is £2. So you make £2 per profit per box. Okay, so that's an easy mark there out of your 5. Next is obviously to work out how many boxes fit into this crate. So how many go along here? So let's say across, how many would fit? Let's just check how many would fit. Well, you would have 210 divided by 8.4, which is 25. 25 boxes would fit backwards. Let's check how many would fit that way, just to check. 120 divided by 6 would be 20 fit back that way. And how many fit up? Well, you'd have 100 divided by 4, which is 25 boxes. So 25 can go along that way, 20 can fit backwards, and 25 can fit up. So in total, how many boxes could you fit in the whole thing? Well, total boxes, okay, would be 25 times 20 times 25, which is 12,500. So profit, you get £2 for each of those. So it's 2 times 12,500, which is £25,000. So you would get £25,000 profit if you sold a full crate of boxes. Okay, now we'll move on to the next exam question on volume. As always, pause the video, have a go, then I will start talking again in 10 seconds and you can mark your work and check if you got it right. Here we go. Okay, so it talks about a gold bar with the trapezium cross section, and it asks you to work out the cross sectional area of the bar. The cross sectional area is the area of the face of the bar. Now you should be able to use the area of a trapezium formula here. I've done this in a previous video, so look there for further information, so I'm not going to spend too long. The area of a trapezium is a half, the parallel sides added up, so 7 plus 11, okay, and then multiplied by how the perpendicular distance between these two distances, which it tells us is 5. So the way I type it in my calculator, 7 plus 11 is 18, I half it is 9, and I times by 5, and I get 45, and the unit is centimeters squared. Okay, then it tells you that the gold has the following density. Work out the mass of the bar, give your answer in kilograms. Now, you should be thinking back to a couple of questions ago. Density. Either you did a revision card and remember that density is, remember, mass divided by volume. Or you remember from science you may have done a density triangle and it would look like something like that. If you want to work out density, it's mass over volume. Okay, if you want to work out mass, you cross it out, it's density times volume, etc. Or better still, I said, look at the unit. It tells you density is grams per centimetre cube. Per means divide. You get for free that density is grams, which is mass, per, which means divide, by volume. So rearranging, mass must be density times volume. Okay, well, What's the volume of the shape? The volume it's a prism, so it's the cross-sectional area times by the depth. So the volume is 45 times 16, and you would get 720 centimeters cubed. So therefore, what's the mass? The mass is the density, which is 19.3 grams per centimeter cubed, times 720 centimeters cubed, and you would get 13,896, and the unit you would get out of that is grams. It asks for your answer in kilograms, so you divide this by 1,000, is 13.896 kilograms, and you're done. Nice easy question, 2 marks and 4 marks, 6 marks, but very gettable question, especially now if you're remembering what density is all about. Okay, last question now. As always, pause the video, have a go yourself. You can use the formula booklet for the next question, it may help you. So try and work out the volume in the next question. After 10 seconds, I'll go through. Here we go. Okay, we are asked, we have a test tube that has a cylinder, here's the cylinder, and a hemisphere. Hemisphere means half a sphere, as shown. Work out the volume of the test tube. Well, to work out the volume of this, we would work out the volume of the cylinder and the volume of the hemisphere and add them together. Okay, that would be an easy way of doing it. To get the volume of the cylinder, well, you'd need to work out that area and times it by the height. But you don't know the height, you just know the total height of the test tube, which is 12. So how could you subtract off this distance here to work out just the height of the cylinder? Well, a little bit of ingenuity here. If this is 6, which would be the diameter, the radius must be 3. And therefore this would be applying the bottom, the radius must be 3. And because it's a sphere, that distance there must be 3. Because the radius from the center of the sphere must be 3 all around. So this bit here is 3 centimeters. So this bit here in particular must be 9 centimeters. Okay, and then we're almost there. Let's work out the volume of the cylinder. Well, the area of the circle is pi r squared, pi times 6 times 6. And then you multiply that answer by the height, which we've got is 9. Okay, so you work that out, pi times 6 times 6 times 9, and you get 1017.88, and the unit centimeters cubed. Well, what's the volume of the hemisphere? Well, the volume of the hemisphere, a hemisphere is half a sphere. So it's 0.5, so it's half of the volume of a sphere, which if we look in our formula booklet, we're given that to us as 4/3 times pi times r cubed, and r in this case is 3. So times 3 times 3 times 3. Okay, we work that out, we type that into a calculator, so 0.5 times 4/3 times pi times 3 times 3 times 3, and we get in total 56.55 centimeters cubed. You add the two, total volume is therefore 1017.88 plus 56.55. Add those together and you get 1074. I'm just going to round it to the nearest centimeter cube, centimeters cube, and I'm going to say nearest whole number. Just tell the examiner how you've rounded it. And that's it, we're done. So they are all the main questions that have come up on volume in the AQA Unit 3. I hope you found that video useful in your revision.